5-4. Oops, sorry, I almost hit you in the face.
You're all good. I only would have cried a little bit.
In this one here, I want to try and get through as much of this as I can because I know a lot of you guys are probably bailing out here for the band stuff and all that here real soon. So I need to get through this real quick, so please hold all of your applause to the end. What we're doing here today is we're going to talk about imaginary numbers. They're the numbers that really don't exist, like 11 billion, 11 billion. I know it is, I know. But what we're looking at here is, can you solve, oh wait, oh, okay, we got two for Well, she is a foot taller than you, so that kind of helps. Hurry up!
They look really sad.
Oh wait, you know what, we'll come back to it, because there's all people, you guys aren't leaving right away, are you?
What do you mean?
You don't have to leave early, because
Oh,
no, you guys, we come back to it?
You're gonna forget.
No, I won't.
You forgot Jack's the other day.
Just don't worry about it. Anyway.
That's hilarious.
What do? I square it both sides. So if I take the square root on both sides, I get x is going to equal plus or minus the square root of -1. Which means, think about what square root means. What are two exact values you multiply together to get the value of the radical? Are there two numbers that are exactly the same that you multiply together to get -1? No. So what in the world do you do? Well, in math, we like to make stuff up. If there isn't a way to do it, we're going to make a rule to do it. So we used our imagination.
Have you ever had to sneeze but you can't sneeze?
Yeah. This value called I is called an imaginary number. And you normally use a lowercase I for this. Most books use a somewhat cursive italicized I value. So I just kind of put a little I with a small tail on it and just use I's. Okay? I is the square root of -1. Therefore, if you work it the other direction, I squared would equal -1. Okay? The square root of -1 is I, and I squared is -1. It works going both ways there. So what we're doing here is it's going to allow us to be able to solve this. If I want to simplify the square root of -8, it is not 8i. What happens is, think about when you're working with square roots. Square roots can be broken down into perfect squares because you can multiply them through. What you do here is you factor out the -1. And then you're left with the square root of 4 and the square root of 2. You're breaking it off into chunks that you can work with. Anytime you have a square root of a negative, that means you're going to have an I in your answer. That's all it really means. Okay. We know the square root of 8 is 2 root 2. So therefore, the square root of -8 will be 2i root 2. When you write it out, whole number first, imaginary, and then your root. If it was with an equation, if you had to solve and you wound up, x squared equals -8, you'd wind up with plus or minus 2i root 2, and so on. The rules for all of that still hold true. That doesn't change. No problem. Okay? This allows us to do so many other things. For example, this equation in the middle. Yesterday, we weren't able to solve something like this because we wound up with negative solutions. You guys probably saw this before in Algebra 1, and you said, oh, can't do it, no solution. Well, you just weren't using your mind. You weren't using your imagination. I'm just making a lot of stuff up today. It's fun. Okay. So if I have to solve the equation 2x squared plus 3 equals -13, what do I do? Subtract 3 and I get 2x squared is -16. And lo and behold, we get square root x squared is -8. I have to take the square root over both sides, so what's my final answer?
2i plus or minus 2i over 2.
What this kid next to you next to
Exactly. I just ran out the strip ball. Okay? Straightforward, nothing crazy. The idea here is that you have to remember that I equals the square root of -1, and I squared is -1. That's really all there is to it. Everything else holds true. Okay? Negative, the square root of -1. Yeah. Equations are very easy. But I also need to show you this.
Whoa, no, no.
Whoa!
Hey,
What happened here is I am writing out what's called a complex ordered pair set. We will not graph anything in the complex ordered pair. There are imaginary number graphs that you can do. I'm looking at an imaginary graph right now.
Oh.
This is nothing more than combined like terms. Okay? When you have I values and you're adding or subtracting, and I'll show you this here in a second, notice the first set is 2 plus I plus a second set, 3 minus 7I. Since what's in between there is an addition symbol, I can go ahead and combine like terms like those parentheses didn't exist. JC, you don't look like you're buying it.
No.
Okay. So what happens here is I do this. 2 plus I plus 3 minus 7I. What do you think is going to go first? Numbers or ones with I's?
Numbers. Oh yeah, because they're imaginary.
Yeah. So hold on now. 2 plus 3.
4, 5.
What is the coefficient in front of the first I? What will 1I minus 7I equal? And you're done. It is a combined like terms problem. That does not change whatsoever. This is ridiculously simple. Okay? Exactly. What the weird one is, no, I'll show you multiply. It's a little bit, but it's not that bad. Is when you have subtraction. Notice you're subtracting a quantity, which means what do I have to do with that subtraction symbol? Yeah. You treat it just like you would any other time you had a negative in front of a grouped parentheses. You distribute that negative to both terms, just like you would before. So you wind up just rewriting 3 minus 2I minus 5 minus 6I. I'm just distributing this negative to both parts. If you want to think of this when you're adding and subtracting, treat I like you would a variable. And I know all of you guys know how to combine like terms with variables. Those rules haven't changed since you first learned them. It just so happens that I, as we get going, something a little fancier. But you treat the process the same. So what's 3 minus 5? And then negative 2 minus 6. And you're done. It's very simple. What changes is when you have multiplying.
I didn't even see
That set me up to do what? Foil. Yeah, distribute. Exactly. Distributing is just a fancy way of saying foil. Okay? And you would foil it just like you would anything. But yet there's one twist at the very end. Dun dun dun. Exactly. First, 2 times 1 is 2 times 2I. And then what's going to be negative 3I times 2I? negative 6i squared. Good. Exactly is what we're going to do. Watch what happens. 2 goes first. What's 4i minus 3i? It's 4 minus 3.
Well, okay.
Oh yeah, you're right. I'm sorry. I got it.
It's okay. Now take a look at the last part. What does I squared stand for?
-1.
So you wind up with minus 6 times negative 1, which is
+6.
plus 6. So it's 2 plus I plus 6, so it's 8 plus I. The weird part always happens when you have this I squared. Yeah. I squared can always be simplified to become negative 1. That is as weird as multiplying by i's gets. It really is. Yeah. Okay. Yes, sir.
Is I equal to square root of -1 just because we say so, or is there some mathematical proof?
Yes. Because what happens is that any compound number can be rewritten as a bunch of prime numbers. Like 2 can be written as 2 times 1, 4 is 2 times 2 times 1, 8 is 2 times 2 times 2 times 1, 12 is 2 times 2 times 3 times 1. So anything that I do when I'm multiplying things out, if it's a negative value, I can rewrite that as, like, negative 8 was negative 1 times 2 times 2 times 2. Negative 5, negative 1 times 5. See where we're going with that? You can pull out that negative 1 value in any single negative number, whether it's underneath the radical or not. By simplifying this to become what we call the imaginary number, this number doesn't exist, but it has to in order for us to math, that's where we came from. Okay? You will use imaginary numbers when you guys get in physics with some electrical circuitry, with ohms and resistance, I believe. That's about the only practical place that they use it a lot, unless you're in an algebra 2 class and they make you do imaginary numbers. Okay? Let me show you another one. Uh, 3 plus 4i times 7 plus 2i. We're going to FOIL again. Combine like terms and simplify. (21) plus 6i plus 28i plus 8i squared. Okay. I squared can be rewritten as negative 1. So I have 21 plus, well, 6 and 28 is 34i. This is plus 8 times negative 1. Gentlemen, come on. And then it's just a matter of taking 21 minus 8. And you get 13. The reason that I want to make sure that you guys see how really simple it is to FOIL stuff out is so that you can rationalize denominators of I. Just like a square root, they don't want square roots in the denominator. You also don't want imaginary numbers in the denominator. So what we do is we multiply by what's called a conjugate. I'll show you that. Still going to be multiplying. Before I show you what's called a multiplicative conjugate, how would you factor that?
Square roots.
No. You're thinking solid. I'm just saying the actually factor, you get x plus 7, x minus 7. What I want you to notice here is that when you have what's called a difference of squares, there's no middle term. You should have an x squared term and a perfect square term on the tail. Everybody see that? And the reason they're able to do that is because it's the same values, opposite signs in the middle. That eliminates the middle term. So if I think about what I want to multiply this by to get rid of the I, I'm always going to multiply by the exact same values, but change the sign in between. Because when you FOIL that out, you will not have a middle term. I goes away. Watch. Just with the denominator for right now. Oops. When I FOIL that out, I get 9 minus 6i plus 6i minus 4i squared. What's 6i minus 6i?
0.
They go away. What's I squared? So you get 9 minus 4 times negative 1, which is I went away. See it?
Bye, Mr. Murphy.
Get it? I went away. The assignment will be posted online for you guys. I've got 12 problems for this. It's pretty straightforward. I'm getting them. Okay, because I know it's a bunch of you got to bail out. Now, if I multiply the bottom by 3 minus 2i, what do I have to multiply the top by?
3 minus 2i.
Exactly. I'm multiplying it by the exact same thing because,
Bye, Marty.
yeah, I'll have it online for you, or have somebody text it to you, or whatever. Okay.
I got you.
Notice what I've got here. I'm multiplying it by a factor of 1. I'm changing the shape of the actual, whatever it's called, algebraic statement. Expression, that's what it's called. I forgot what it's called. I'm changing the state of the algebraic expression. By multiplying it by a factor of 1, I have not changed anything, just like we multiply top and bottom by the square root of 5. It's the same exact process. We FOILed out that denominator, we got 13. What do you do to the numerator then? FOIL it. FOIL it and simplify. So you FOIL out the numerator. We know the bottom was 13. We get 6 minus 4i minus 3i plus 2i squared. And is it okay to have I in the numerator?
Yeah.
Absolutely. Absolutely. So we just combine them out. We get 6 minus 7i plus 2 times negative 1 over 13, which gives you a final answer of 4 minus 7i. And that's the final answer. Exactly. Your book will rewrite it as 2 separate fractions. You don't need to.
So if we don't want to buy any
And the process of doing that is exactly the same every single time. And after you do a couple of them, you might just happen to recognize the pattern that occurs. There is a pattern that happens each and every time. Am I keeping you guys up for something? Walk away. Just try to. Yeah, go ahead. It's online.
Hey, this is me. Thanks, Mark.
That's what I'm here for. Let's try this one. Same process, guys. Same process. I know I've kind of flown through a little bit of this because I know we don't have that much time. Oh, we still got 15 minutes. Sweet. I went through it real quick because I knew where I was going to lose people. I didn't realize I had that much time left. So we're doing great. You're doing fine.
Oh, we're going to high five.
Yeah. I have 4 plus 3i over 5 minus 2i. What do you multiply top and bottom by?
5
5 plus 2i. It is multiplying by its conjugate. Okay. We're going to go ahead and FOIL this out. I know the denominator is going to be 25 minus 4i squared. It's very straightforward. The top is going to be a little bit more work. Let's see, 20. What? All I did was FOIL.
No, I know.
Okay. So in the numerator, to bring us down here, sometimes run out of space. I have 20 plus 23i. Will that be minus 6?
Yeah.
Okay. All over 29. Remember, I squared is -1. So I have here 25 minus 4 times -1, which is 25 plus 4. Okay. And then lastly, that's just it. Yeah.
It's like, it's not for this one, but if the 14 and the bottom is rounded or, like kind of great, would you be able to simplify further?
You can if you broke the fraction apart. Normally you're not going to see that. This what can happen, and then it does every once in a while. What she's asking is, what happens if you get something like this? Can you simplify that?
Yeah.
Not multiply by 2. I'm saying that since this is the fraction up top has 2 parts with addition, it's technically the exact same thing as this. You can do that. But let's say it was, can I just write this as 4? No. Correct. What you're thinking of, I mean, you can go ahead and do this and do 11 over 2 plus 4i. That's more work.
What if it was like 15 on the bottom and then 3 plus 5i?
15 on the bottom, 3 plus 5i. Oh, I see what you're saying. Pull out a 3, then you'd have 1, or, well, you can't pull out a 3 because it won't go. I know what you're thinking. Do you want to rewrite it as 1/5 plus 3 plus I over 3? You don't have to.
Yeah,
The only time I'm worried about, see how I had that one where it was all divisible by 2? If you could do something like that, that's fine.
no.
I thought it was this.
Yeah, but you said it would be separate, so it would be 3 over 15 plus 5i over 15.
Yeah. And then you would get this if you did that.
Oh.
See, that's a little bit more work than you need to worry about. If everything happens to be, 25, 10i, and 5, then that's okay. But more often than not, you probably aren't going to get something like that. Okay. So, what's the other one I had? Let me give you the double whammy.
Whoa.
Is there an imaginary number button on our calculator?
There is, but the calculator won't do all the rationalization for it.
Where is it?
I'm looking at it right now. Oh!
I have a note from my mom.
You have a note from your mom about where your calculator is.
Because her mom couldn't come back into the couch because her sister's practice back in. Yeah. It was raining. You can talk to her on the phone right now.
No, it's okay.
Second decimal.
What do you think at both my top and bottom eye here?
I
Good.
equals I.
Yeah.
Oh, snap.
Oh, sorry, this was minus.
-1.
You guys are so easily amused. It's quite funny.
Thank you.
Yeah. Anyway, so you go to FOIL this out. You go to FOIL out the denominator. Just be careful. You wind up with 36 minus I squared times 2. Okay? Normally I would put that I first, but since it was in front, see how I'm doing there? I times I is I squared. Root 2 times root 2 is 2. This becomes 36 plus 2. So the denominator is 38. Okay? The numerator, 36 minus 6I root 2 minus 6I root 2 plus I squared times 2. Just straight foiling out. What will negative 6I root 2 minus 6I root 2 equal?
12.
Very good. Won't equal 0 because of the same sign.
Oh.
So 36 minus 12I root 2. What's I squared times 2?
-2.
Excellent. So your final answer here becomes we okay on that? You can, and this is an example of one thing that you can simplify. Because what are all of these divisible by? 2. You can take out a 2. Okay, you can take out a 2.
You worked on it.
Well, you should recognize 2s or 3s. So you get what? 17 minus 6I root 2 over. We okay on this? Let me give you a couple props. It's on page 277. Is this the right one? Yeah.
Wait,
You can keep it. It was question.
Yes, all of them.
I just get the first time I did it. I stood up right there.
It's 12 problems, ladies and gentlemen. Okay? There's 12 of them. It might take you 15 minutes, 20 minutes tops. Okay? I will. Hey, Tara, would you do me a favor, Tara? Will you write that on the board next to you?
Yeah.
You're in charge of that every day now.
Okay.
I have nominated you as board writer person.
Well, I mean, I sit right here. It's all
You
the
should get a plaque. I'm going to give you a plaque. Okay? Okay. You guys got it?
Wait, 1 sec.
1,
5 seconds.
2, 3, 4. I have a bit of pain. Yeah.
Okay, I
Hold on, guys.
how you got like -6 I root 2 and then another -6 I root 2.
When I was foiling up top here, I got 36, and then I went to the outside. -6 I root 2, -6 I root 2. That's all it was. Okay.
This is easy.